This is part 3 to test review number 1. Section 1.7 is all about inequalities. This number 22 is just your basic inequality. With this kind of inequality, you want to clean up each side first. So that stays the same. Here, distribute the negative 4x minus 32 plus 10. Combine your like terms here. Left side staying as is. Negative 32 plus 10 is negative 22. Now you want to get your x's on one side and your numbers to the other, and the easiest thing to do is to add 4x over here, which makes this a positive x, and then add 6 to both sides, which gives you negative 16. So this is x less than or equal to negative 16. That is solving it. You're asked to graph, so you have 0, negative 16 way down here. Less than or equal to is going to give us a bracket, and we're shading to the left, which leads to interval notation. This is going to be what I call a backside bracket. So the negative 16 is that end with the bracket facing that way, and where that is going is way down to negative infinity, and the infinities always get a curved parentheses. Remember, on plain old inequalities, if you have to divide or multiply by a negative, you must change your inequality sign around. So pretend that this had been negative x minus 6 less than or equal to negative 22. When I add 6 over here, I get negative 16. To solve this, I need to divide by negative 1, which tells me to change that sign around and then do the arithmetic. So if that had been a negative x there, that's what would have happened solution-wise. We also can do inequalities with absolute value. I'm going to start with this one first. This is a plain old absolute value of 2x minus 5 is less than 7. Absolute value still requires two cases, but when you're dealing with an inequality with a less than, there is a shortcut setup, and the setup is this. You put 2x minus 5 in the middle, keep the less than signs, put 7 at that end, put negative 7 at that end. Those are your two cases. There's a negative case right there, and there's your positive case. This is just easier to solve. To solve an inequality like this, you want to start inside here so that you get the x alone. So let's add 5 to all three places here, which gives me negative 2, less than 2x, which is less than 12. Still working here to get the x alone, so we divide everything by 2, which gives us a solution of negative 1, less than x, which is less than 6. Here's our lazy man graph. Negative 1 to 6, we're going to shade between those two numbers. And because this is plain old less, it's going to get the curved parentheses, which gives us this interval notation also. Number 23 had an extra step to it. That's why I wanted to do it second. It's like the absolute value we did in section 1.6. It's also like the square root problems. You need to have the absolute value bars isolated before you separate out your cases. So now this says absolute value of x plus 6 is less than or equal to 8. It is less than, even though it's less than or equal to, it is still less than, so I get to do this cute little shortcut setup. Negative 8, less than or equal to x plus 6, less than or equal to 8. I just need to solve, get x alone, so let's subtract 6 from all three of these columns, which gives me negative 14, less than or equal to x, less than or equal to 2. Here's my graph from negative 14 to 2. But because this is less than or equal to, we're going to get the square brackets on here and shade between, which gives me that identical interval notation from negative 14 to 2. Absolute value greater has to be an or setup. You can't use the shortcut thing we just did on the last two problems. Because this is greater, you must set up two separate inequalities with the word or between them, greater. So 3x plus 8 greater than 4, exactly as is, or 3x plus 8, but now it's going to be a negative 4, and because it's a negative 4, we must change that inequality sign. It's kind of like dividing by a negative. So there's your two cases. Common mistake is this right here, people forgetting to change that inequality sign around. So two important things. Greater, you're going to have to set up two separate cases with the word or, and then remember on the negative case to change that inequality sign. Now you have two easy inequalities to solve. Subtract 8 from both sides, divide by 3, and that's x greater than negative 4/3. Notice we divided by a 3. We did not change the inequality sign around. Even though this right here was a negative, we divided by a positive 3 and did not change the sign. Over here, subtract 8 from both sides will give me 3x less than negative 12. Divide by 3, and this is x less than negative 4. And when you have an OR problem to put it on a graph, you're going to find those numbers on your number line. Be sure that you put them in the proper place size-wise. Greater than negative 4/3 is going to go to the right with a curved parentheses. Less than negative 4 goes to the left with a curved parentheses. And then your interval notation, just look at this part right here, will be negative infinity with a curved parenthesis to negative 4 with that curved parenthesis. Union with curved parenthesis negative 4/3, and where's that going? It's going out to positive infinity. Same thing here. This is greater than or equal to, still the same kind of setup. This is 6 minus 2x greater than or equal to 10, or 6 minus 2x less than, oh, forgot my greater than or equal to, less than or equal to negative 10. 2 to solve here, negative 2x, subtract 6 from both sides is 4. I'm going to divide by negative 2. I'm dividing by a negative, so I'm changing that sign around. So I get x less than or equal to negative 2. Over here, same kind of steps. Subtract 6 from both sides, negative 2x less than or equal to negative 16. Divide by negative 2, and because I divided by a negative, that sign needs to change, and this becomes positive 8. And there's still the word or in between. So I have to put those two on my number line. Negative 2 is smaller, so it goes down here to the left. Less than or equal to negative 2, I missed the line there. Let's just make it bigger. Goes that way. Greater than or equal to 8. Goes that way. Interval notation, negative infinity to negative 2. Union 8 to infinity. Curved parenthesis.